All right, guys. Yeah, so uh, we did the best we could with attendance. So hmm, I'll periodically be trying. I'll try to. You just you want to be make sure that your video is enabled today, um, so that I can we'll take a moment to try to do attendance as best we can. Um, but you definitely want to have your video enabled when I do decide to go take attendance. Um, you know, we can make sure that we see you. Did anybody have any questions? Okay, so this week I know that nothing new has come up on Pearson. That's because on Wednesday, exam one is going to open up, right? So I hope everyone's having a good what is it, Labor Day weekend. I know we're here, but it's only 50 minutes. It's not too bad. Our exam one is Wednesday. Our exam one is Wednesday. It'll open up on Wednesday. It'll close on Saturday at midnight. You get unlimited attempts, so we'll see how it goes. I'm just gonna kind of let that be. But yeah, it'll open up on Wednesday. So what we can do today, we can just go through problem sets. So like anything you have questions over. If there aren't specific questions, if we meet 4 times in a week, I'll probably take a day on each section. That's about the right rhythm. There's not really a study guide. It's just you get as many attempts as you like. Are there any questions? Go ahead.
So like, do we have to do
Wait a minute. Wait a minute.
the helix
Wait.
also?
Wait. Wait. I don't know. You sound like I can't understand anything you're saying. I don't know if it's my computer or yours. You might have to disconnect the audio and reconnect it back.
It might,
It sounds real choppy. I don't know why it sounds like that. So just try disconnect it and reconnect it back. Hopefully you guys can hear me okay. Also, if you can also type your questions into the chat. I got a long hair. Oh my goodness. So the chat. We are monitoring the chat, and let's just kind of go ahead and hop into some problem sets until we get specific questions. Um, I guess let's work. We could work backwards. Let's work forward because I know we were working on 1-3 last time. The exam is going to be over sections one. Only the stuff that we've talked about. We've only talked about 1-1, 1-2, and 1-3, right? By default, a mathematics exam is cumulative because, like, for instance, when we get into section 1.4 next week, uh, you can't really do the stuff in the later sections without knowing the stuff in the previous sections. So by default, mathematics is cumulative. Let's let's take some time to look at section. We'll take today to look at 1.1. That's a good question. Let's just kind of keep with what we're doing right now. I'm not gonna. I can't say yay or nay because I did see an email about that. So we will. We'll discuss that more tomorrow. Okay. I had to kind of ask my supervisors about that one because that might be the case. I saw a brief email. I definitely need to ask them. Okay. So, but for today, we're gonna go ahead and take some time to go through section 1.1. Okay. You are really trying to move slow, my friend, and I don't know why. Like, you got plenty of space. All right, you're just bugging today. I don't. I think I need to reboot the computer, but I'm trying not to because I know this is going to eat up our valuable time. Okay, let's get this to go. I'm gonna jump around, do my random. I think it's gonna. I always like to start off with 13. I'm gonna hit open. I'm gonna type 13. Um, hey Google, give me a random number 1 through 20. Oh, look at that boy! I got it. I got it today. I got that one. So we got 13. Hey Google, maximize your volume. Hey Google, maximize your volume. All right. So again, we'll try attendance. Again, the best way to get attendance today, you definitely want to have your video enabled because periodically I'll show the whole class. We'll do a screenshot, and I'm going to have to use that for attendance. Also, it's probably a good idea to go ahead and have your Zoom name be something like professional. You can always switch it later, and not, I think when we are in class, you can't really do it, but before you get in, we can actually you can set your name. So that's probably a good idea. So let's look at question number 13. This comes from section 1.1, and I'm going to take notes over on the tablet here. Let's go paper. And unless there are specific questions, if there are specific questions, then we'll address them. But otherwise, today we're just going to focus on 1-1. Again, on Wednesday, exam 1 over 1, 1, 1, 2, and 1, 3 will be open, unlimited attempts, and things of that nature. Okay? But, and the exam is like a long quiz. So if you've done any of the quizzes here, it'll be similar, just more questions, right? So this comes from, this is our homework. Wait, let's make this thicker. Okay. Yeah, that's probably better. This comes from our homework. This comes from week 1, 1.1, graphs of equations. Graphs. I don't know what I'm writing. Let's just write it here. This comes from 1.1, graphs of equations. Okay. This is question number 13 from this assignment, and this question comes from 1.1.45. It says, test the equation for symmetry with respect to the x, y axis and the origin. Okay. So the first time I'll run through it, I'll do it the way that the text wants to do it, and then I'm going to do I'm going to do the analogous first, what I feel like is a little bit faster. So let's hop over to the tablet. So I'm going to do this. Let me get a copy of the original first. So the original, I'm going to say test for symmetry. And the original is y equals negative 7x squared. Uh-oh. Scab. Ooh. 7x squared plus 5x to the 6, right? Test for symmetry. Okay. So let's hop over to the tablet. Let's move you out of the way. So I'm going to do this in the way that I see it, right? So given something like this, I would do a test for even, odd, or neither first, because once we get the answer there, that helps out a lot. So I'm going to do f of x equals negative 7x squared plus 5x to the 6. Let me write the definition of even. So the definition of a function being even means f of negative x equals the original, right? The definition of a function being odd is going to be f of negative x equals negative of the original. Okay? Even also means y-axis symmetry. Okay? Odd also means origin symmetry. Okay? So this is why, because I can do one test and I'll get a lot of information, as opposed to having to do a test for x-axis, test for y-axis, and a test for origin. I would start with even or odd, and then if that doesn't work, I would go back and do the other test. Okay, so I'm just gonna do a test for even or odd, right? So if we do f of x, I'm gonna replace all my x's. First, I'm gonna replace each x with a blank set of parentheses, and then inside the blank parentheses, I'm gonna put negative x, and negative x, right? Okay. All right, let's keep it moving. So if we say negative x squared, that's going to become positive, right? So we're going to get negative 7x squared. Another even, so plus 5x squared. Is that the original? Let's see the original. Negative 7x squared plus 5x. So this is equal to the original. So notice, that's the definition of even. So then that means that... Sorry, guys. That's the definition of even.
No, yo, Professor, you wrote 5x squared is to the 6.
Okay. You're right. Oh, but I think we still got the same it's still going to give us the same result. You saw me rubbing my eyes, so I'm like, not all the way there, but it still holds, right? So that's.
I have a question.
Let me check it real quick, and then we'll entertain questions. I feel like even is correct. Not feel like, but even is correct. So let's hop over it. So that means it should be y-axis symmetry. Let's check it real quick. Is it symmetric to the x-axis? So I'm going to say no. So notice the highest exponent is 6. That should mean that the long-term behavior, they go off in the same direction. It's kind of like going to be like a W. But I'm going to say no for x-axis symmetry. Okay. I'm going to say yes for y-axis because we said it was even. And in order to have, let me see, it can't be this one either, right? Because if you have 2, then you guarantee the third. So I'm going to say no. Okay. All right. There was a question. Go ahead.
Can you go back to what you was writing?
Mm-hmm.
So when you did the -7 (x squared) and you squared the -x to make it positive, why is there still a square there then?
Oh, -x. Okay. So what does, you're talking about this guy right here, right? In the red circle?
Yes.
Okay. Let's copy that, right? We're going to copy this. Copy, paste. Okay. So what does this mean, right? If we do -x squared. -x squared, that means -x times -x, right? But that's the same as, double negative is positive. Is that okay? If double negative is positive, then we're left with x times x, which is x squared. Okay?
Okay.
Yep, no worries. Okay, so I think we got that one. All right. So if there aren't any specific requests, I'm going to jump to another one at random. Let's go ahead and type open. And I think you guys, I'm going to go 20 because that's the first number that I saw. Hey, Google, give me a random number 1 through 20.
Pancakes from all recipes. This recipe serves
Hey, Google.
and takes about...
Stop. Hey, Google, give me a random number 1 through 20.
10.
10. Let's see if anybody got 10. That was a long one. Open. Okay, let's see. Nobody got it? Oh, that sucks. Okay, let's go look at question number 10. Numero 10 is this one. Okay. It says, without sketching the graph, find the x-intercept, y-intercept, and graph the equation. Okay. So to find the x-intercept, let's take some notes here. So let's start a new page. Go ahead. Go ahead. So this is question number 10, right? It comes from section 1.1, question 33. The original, we got this 3x plus 2y equals 18. And we're asked to find the x-intercepts, the y-intercepts, and graph it, right? Let's hop over to the tablet. Boom, just like that. Thanks. That's right. All right, so for the x-intercept, right? So to find the x-intercept, again, what do? We set y equal to 0, right? So it should be fairly quick. 3x plus 2 times 0 equals 18. So then notice this goes to 0. So then we have 3x equals 18. Divide both sides by 3. X equals 6. Okay. Let's go ahead and find the y-intercept. I think now x equals 6, or you can write, 6 comma 0. They both mean the same thing. It's just that Pearson, you want to match whatever format they want it in. Okay. This is why I do unlimited attempts, because sometimes I know students get the things right, and it's just a formatting issue. For the y-intercept, we set x equal to 0. Okay. So we got this 3 times 0 plus 2y equals 18. So then 2y equals 18. So then y equals 9. Or you could say 0, 9. Right? They mean the same thing, it's just, again, formatting. And we'll graph. We can actually just graph those intercepts. Let's hop back over to Pearson and submit these results. Okay. So what is or are the x-intercepts? Notice that the highest exponent is a 1. We got x to the power of 1, y to the power of 1. So a straight line makes sense. Typically, straight lines have one x-intercept and one y-intercept. We're going to try the attendance again soon. Type an integer, use commas to separate. It doesn't say an ordered pair, so I'm just going to type 6 and hit enter. Awesome sauce. And then the y-intercept, we got 9. I'm going to type 9 and hit enter. Awesome sauce. Oh, that was it? I thought they wanted us to graph. Oh, without sketching, find the x and y intercepts. Oh, I thought it said and graph. Okay. It said of the graph. Give me just a moment. Oh, it's only 25 minutes left. Party's almost over. What a bummer. Okay. Does anybody know that reference? I'm just curious. We're halfway. Party's almost over. What a bummer. Okay, anyway. What am I looking for? I wanted to look for something. Okay. Let's just go ahead and do this. There was something else I wanted to do. Okay. You guys are ready. Hey, go. Oh, I need to choose a number. Let's go 8. Give me a random number 1 through 20.
18.
Oh, not bad. Close. So, oh, no. See, that's why 18 is after the close. You was fast, but not fast enough. I don't know if you heard it or not, because that was pretty quick though. I got 8. Okay, so I'm not gonna count that one because that was I know the audio went and it got in there after the close. It was quick though, it was close. All right, let's see. So we got 18. Just having some fun, trying to be light, right? So it says find the equation for the circle with the diameter whose endpoints are this. Equation of a circle. Okay. So if you have a formula sheet, it probably is a good idea to add I think that's the standard form of the equation of a circle. This is question number 18 from this assignment. It comes from section 1155. Let me go ahead and write the general form of the equation of a circle. I think it's x minus h squared plus y minus k squared equals r squared, right? Now it says the diameter, endpoints, let me see. The endpoints of the diameter, we have 4 comma negative 5. Oh, attendance. That's what I wanted to check. And negative 1 comma 3. Let me hop over and see if attendance is working right now. Let me see. I don't really want to stop the stream though. Let's reload. Yeah, you still not working? Yeah, we'll try to take attendance a little bit closer towards the end. What I could do, let me go users. Let's go here. Let's go to users. Is this everybody? At least I got a copy of them. I know it could be seen. I ain't gonna worry about it. Okay. So we're gonna hop this way. So I know I at least have one copy. I'm just gonna have to rely on that. Okay. So let's hop over to the tablet. See where you come back. I think we left off here, right? So we want the equation of the circle who the endpoints of the diameter are these 2 points, right? So for the equation of the circle, the h and the k are the coordinates of the center of the circle, right? And so we need the center and the radius. So if these are the coordinates of the endpoint, how can we find the center and the radius with given this scenario? Can anybody walk me through this? Again, for the standard formula of the equation of the circle, we need the center of the circle and we need the radius. How can we get the center and the radius if we have the endpoints of the diameter? Okay, distance formula. What about the distance formula? What would that tell us? What about the diameter?
It would tell us how long the diameter is, so then we could divide it to find out what the radius is.
Divided by what?
By 2.
Yeah, by 2. Okay, I thought you said by 3. I was like, whoa. Yeah, so we can use the distance formula divided by 2. That'll tell us the radius. How can we find the center?
Use the circle formula.
What's the second formula?
The circle formula.
Let me see. That's going to tell us about the graph of the circle, but we're trying to build that formula. So how can we use the endpoints of the diameter to find the center of the radius? I mean, the center of the circle. How can we find the center of the circle? What is you said the radius is half the diameter, right? So if the diameter cuts the circle in half, or we want to find the center of the circle, how can we find the center of the diameter? What formula have we talked about?
The midpoint formula.
Midpoint formula, right? So this is like a twofer. I call this a twofer. So with this question, we can use the distance formula to get the radius, and we can use the midpoint formula to get the center. Okay, I think we got a plan now. So let's start off with the distance formula. Again, some more formulas to add to our sheet. So the distance between 2 points P and Q is going to be, we got the square root. I think it's x2 minus x1 squared plus y2 minus y1 squared. And the square root of all of that. Okay. So oftentimes when I get a set of points, I like to automatically label x1, y1, x2, y2. Okay. And then the midpoint formula is the average of our x's, average of our y's. So that's going to be x1 plus x2 over 2, y1 plus y2 over 2. Okay? Average of our x's, average of our y's. It's okay. Okay, let's start off with the distance formula. So the distance is going to be what? What's our x2? It's going to be -1 minus 4, whatever the answer is squared, plus y2, which is 3 minus -5, whatever that answer is squared, and then we take the square root of all of that. Okay? So that's going to be the square root of 25 plus 64. Let me see, that's 80, is that 90, 99? No, 80, 89. 80 plus 9. So then the radius is going to be square root of 89 over 2. Hopefully we didn't make any mistakes there. And then the midpoint, average of your x's. So we're going to say, I think it's 4 plus -1 over 2. And I think it's -5 plus 3 over 2. 3 over 2. And -1. So what that means is that this should be the center. This should be the H. This should be the K. And so then the circle, the equation of the circle is going to be x minus, let's see, x minus 3/2 squared plus y plus 1 squared equals that squared. So I think it's going to be 89 over 4. I think this will work. Okay. That's not going to divide evenly. Okay, let's hop over to Pearson and see how do we do. Let's hop over to Pearson and see how do we do. Okay, 3/2, right? Plus 1, 89 over 4. Is that the diameter? Let me check the diameter again. XY, XY. That's going to be a -5, so that's 25. 8 times 8 is 64. That's 80. Plus 9 is 89. That's not a perfect square. And we got divided by 4. Can we multiply both sides by 4? Oh, there it is. Okay, okay. I was like, how come I'm not seeing my result? Okay. 3/2, right? X minus 3/2, y plus 1, 89 over 4. All right, so our answer is visible there. I'm gonna go with C. Cross our fingers. Awesome sauce. Okay, are there any questions? You guys have any questions so far? If there aren't any questions, I'm just gonna keep it moving. Let's put this back to everyone. Let's type open. Okay. Let's go 7. Something with 7. Let's go 17 this time. Hey Google, give me a random number 1 through 21.
6.
Oh, Mr. Willoughby. Is he the first one? Yeah, Mr. Willoughby. Okay. We got some intuits here, some psychics and empaths. Hopefully it comes in handy. I mean, intuition is actually a real thing. Like, you know, it's like, what does your gut tell you? You know, and like, that's why I encourage people to go with their first mind. The more you practice going with your first mind, the more accurate it'll become over time. But if you're constantly second guessing yourself, what you're going to find is you're going to second guess yourself out of the correct answer. All right, so just trust yourself, and eventually it will serve you. All right, graph, right? So this one is pretty straightforward. We got our y-intercept and we got our slope, so we're going to use that. We got a line. Y-intercept is 6 right here. Let's see. If we go down 2 and right 1, I think that's okay, right? We're going to click the second point, save and submit. Check the answer. Oh, wait. I went down. I should have gone up. I just realized it's right before I hit submit. I don't know. Let me see. Can I move this by typing it? Okay, that's okay. It's a positive slope, right? We went the wrong way. So I think I got it right this time. Yeah, that looks better. I'm going to hit enter or check the answer. Up 2 and over 1, that looks better. Okay. Yeah, moving a little fast, but that's all good. All right. Let's see. Let's go open. What's the time? Let's do 10 because in my mind I saw 10 for 10 minutes. Okay, which is how much longer. I don't want to keep you more than 10 minutes. Okay. Hey Google, give me a random number 1 through 21.
5.
5. I keep getting twice. Nobody got 5. Okay. All right. So let's check out question number 5. It says identify this triangle as isosceles, equilateral, or scalene. Okay. So we have these 3 points, and we want to identify it as isosceles, equilateral, or scalene. Okay. So I already know this is going to be a little bit amount of work. So here, let me mention this. An isosceles, again, 2 sides are equal length. So we have to find the distance between, between the sides of all 3 points. If 2 of the sides are equal, then it's isosceles. If all 3 sides are the same distance, we say it's equilateral. Right triangle is going to satisfy a squared plus b squared equals c squared. Okay, and it could be scaling, which is the 3 sides of different lengths. So let's find the distance between these 3 points. Okay, we could try to graph it, but that's still not going to give us. That's not going to guarantee us to give us what we need to know. All right, because it's not going to be drawn to scale, and we're going to be eyeballing. So that leads to errors. We can graph it. We can plot the points to get a sense, but we still need to follow it up with some algebra to confirm. So we got P is negative 3, 3. Q is negative 3, 1. R, we're going to need some space for R. Negative 3 plus the square root of 3, comma 2. Belly. Let me see. Okay, let's hop over to the tablet. I just got sleepy like all of a sudden. But that's the beauty. Okay, I don't want to keep it more than 5 minutes. So this will probably be our last one. Also, I can make a copy of these notes available. All right. So let's find the distance. Let's pull up the distance formula. Distance is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, and square root of all of that, right? All right. Let's start off. Let's find the distance between P and Q first, all right? So let's see. XY. Okay. We keep going. That's going to be 0. That's going to be 4. Square root of 4. Ultimately, the answer is going to be 2. Okay, you should be able to get to that same conclusion. Let's find the distance between P and R. P and R. Square root XY. All right, so I'm going to say this negative 3 plus the square root of 3 minus a negative 3. That's my x's. And then 2 minus, I don't even know what I just wrote. This needs to be squared plus 2 minus 3 squared. Okay. Double negative, so long story short, this is going to cancel this. Let's keep going. So square root of 3 squared is going to be just 3 plus, that's going to be a negative 1 squared is positive 1, square root of 4 up. So it's at least isosceles, because we got 2. Let's do one more. We need to do QR. So the distance between Q and R. Okay? And again, it doesn't really matter which X and which Y comes first, which point goes first. We just need to be consistent. If we choose the X value of Q first, then we need to choose the Y value of Q first. We just need to be consistent. That's the main thing. Shyster, I don't feel like doing this either. I'm gonna do R first. Negative 3. So we're gonna have negative 3 plus the square root of 3 minus the same thing, so negative 3. That whole thing squared plus, I think this one is, did I do this one already? 2 minus 1. No, I did not. 2 minus 1 squared. Is this equilateral? So that's a plus 3. So this 3 cancels this one. Square root of 3 squared is going to be 3. 2 minus 1 is 1 squared is 1. Square root of 4 is 2. So it's an equilateral triangle. Should be equilateral. Let's hop over to Pearson and see how do we do. Equilateral. Okay. Okay, so I got A. I'm going to hit enter. Awesome sauce. So if it's equilateral, it can't be a right triangle, right? I don't think so. I'm going to hit no. Okay. All right. Okay. All right. I didn't want to keep you all any longer. Let me go ahead and load a copy of these notes so you all can access them. Let's go paper like this. Let's go share. Send it here. Not the 5 p.m. This one, this one, this one. The notes are fine. Right there. It's in the box. That's okay. I probably should have labeled it. Let me label it. Okay, guys. I can't think of any other announcements. Hang tight. Don't go anywhere. Don't go anywhere because I'm going to try to do some semblance of an attendance. Give me just a moment. So this is week 4, exam 1 over sections 1.1 through 1.3 study session. This is for this class meets Monday and Friday at 4 p.m. And then Tuesday, Thursday, 3:50 p.m. I ain't gonna worry about that. Fall 2020. Oh, that might be my next class. I keep forgetting to lock this thing. Let me see if I can take attendance. If I can take attendance, that'll be awesome. So we can stay on track. And let's reload this. Are you loading? Let's go attendance. Okay, so if you want attendance for the 4 p.m. today, just have your video showing. I'm gonna go ahead and stop the stream. Are there any questions before I stop the stream? Any questions from anybody?
Quick question, Professor.
Go ahead.
I just had to log in with my phone because my computer died. I just wanted to know if attendance was good for me.
Yeah, just hang tight.
Alright,
so
cool.
I'm gonna do an impromptu thing. So let's do like this. Let's stop the stream.